Good morning, good afternoon, good evening, based on the time you are accessing this material. Welcome to C Programming, and this is a course taught on coolchat.com. If you are accessing this video on YouTube, please visit coolchat.com to see the course content. So if you are on coolchat.com, under Courses Information Technology, there is C Programming, so you can visit the site's website so that you can see the course content. And this is week 2, so I believe you've gone through week 1. So in week 1, it's basically about the introduction to the course and also how to set up our IDE, Integrated Development Environment, so that we can be, the environment will be doing our coding, and we'll be using code block. So in week 1, we did install code block. In this week, we are going to see how we can write the C programming codes. So this is the introduction of our programming aspect, and this is very, very important, because if the foundation is strong, your programming skills is also going to be better. So let's get started. So what are we going to study for this week? This week we are going to learn about Preprocessor Directives, standard header file, comment, constant, variable, reserved word, and standard identifier and special symbol. Then we see how to declare variables and why we need to declare variables. Then we see some of the data types you can use in C. Okay, so basically this is what we are going to do. So I'm going to zoom the page so that you can see clearer. Okay, so we have the Preprocessor directives. So what are the processor directives? So the Preprocessor directives are commands that give instructions to the C processor, whose job it is to modify the text of a C program before it is compiled. Okay, so before a text is compiled, then the preprocessor it will compile, will modify the text before it's being compiled, and begins with the hashtag, the number tag. So the two most common directives are the include and define. So we use the include to include the header files. So header files normally contains functions which has already been written in C. So if you include that header files, you also have the function. And function is just an instruction or a task. So a block of code that performs a particular task is called a function. And the C environment has written a number of functions which you can use as a programmer, so you don't need to write those functions again. So to use those functions, we normally include the other files. So we use the include preprocessor. Then we also have the define preprocessor, and the defined one is normally used for defining constant. So if you want to use a constant in your code, so that anywhere you have that constant term or key is being replaced by a value, then you can also use the hash, the number tag, then define. So we'll see these two examples. Okay, so we will see the include example and the define example. So we have the preprocessor directive. A C program line begins with the hashtag that provides an instruction to the preprocessor. So that's the preprocessor directive, which has the hashtag. Okay, so it provides instruction to the preprocessor. And you have the preprocessor, a system program that modifies a C program prior to its compilation. So before the program will be compiled, So we will look at what a compiler is. I think in week 1 we talk about what a compiler is, and we said a compiler changes a programming language into a machine language. And we know machines or computers only speak their machine language, which is made up of ones and zeros, which we call the binary codes. That's what the machines or the computer understands. So we have the compiler that changes the code that we write into a binary codes for the computer to understand, to follow those instructions. So before that compilation will be done, the preprocessor is used to modify the C program prior to its compilation. Then we also have a library, which is a collection of useful functions and symbols that may be accessed by a program. So we have the library, which has functions, like I have said earlier on. So the libraries also have functions, and also we have the symbols that you, the programmer, you can access those libraries. Okay, so these are the two preprocessor directives. We have the include, and here we have the stdio.h, which is a standard header file. So this header file helps us to call our printf, scanf, and others. Then we also have the commenting. So we also have the commenting of your code. So later on, we will come to see some of these comments, the types of comments that we have. So a comment is just a text you, the programmer, you write to explain your code, so that if later on even your own code, it may be difficult for you to understand, because previously the way you were doing things may be different from what you are now doing it. So if you don't comment your code, it will be difficult for you to understand your previous codes. And secondly, if you don't comment your code, if a second party comes to update your code, it will be difficult for the person, since you haven't commented it, and it may be difficult for the person to understand your code, even though your code is working. So in a company where you may no longer be available, if you do not comment your code, how is the one who is going to succeed you understand your code? And if he has to do updates, how is he going to do that? So we normally comment our code so that one, we will understand our own code in the near future, then two, others, so that others can also understand our codes. So we have the preprocessor directive, we have the header file, the standard header file, and we have the constant. So we use the define to define a constant, and that's how you have the hashtag, then the keyword define, then you give the name to the constant. So the constant has name, then after that you give the value to that constant. So normally, even though you can use small letters, normally constants are written in capital letters. So in programming ethic, normally constants are put in capital letters. Okay, so later on we'll see how you write some of these variables. Okay, there are some rules when you are naming your constant or your variables. So later on consider that. So to define a constant, you use the hashtag, then define, then the name of the constant, then you leave a space, then the value of the constant. Then we also have the function. So later on we'll see in week 3, we'll talk about functions, where we have some data types of the function as a name, then the function also has an argument. Okay, so all these keywords are reserved words, like int, void, double. They are all reserved words. Reserved words means words that you can no longer use in your code, because once you even start typing, they'll be colored, which means that it is not your variables. Or so if you normally reserve words, you cannot use it because it's already used in the language where it is. Then we also have the printf. So the printf function displays something on the screen. So in week 1, when we did our first program, you saw the printf printing hello world on the screen. So the printf is a function that shows something on the screen, and when it shows the text you put in the double quotation is what is being displayed. Then we also have another function we call the scanf, which we will also later come to see. So the scanf is also used for taking input from the user. So printf is for display information on the screen, and scanf is used to take input from the user. And we will consider this one, explain this further. Okay, so this is basically the explanation of a code. So the curly brackets, they are also special symbol. When you open a curly bracket in the program code, you need to close it. Then if now later on in week 3, when we talk about functions, then you see the reason why it is returning 0. We said the function is int, so your return value is supposed to be an integer value. Okay, so then we also have punctuations or comments in our function. So as I have explained, so these are the explanations we can have. So I will later I will take them one after the other. So we have already explained a constant. So a constant macro, a name that is replaced by a particular constant value before the program is sent to the compiler. So when you define a constant before it is sent to the compiler, it will be replaced by the value you assign over here. So for example, if you have defined kms underscore per underscore mal, so before this value, before it will be sent to the compiler, this value will be replaced by this name will be replaced by the value you assign here before it's being sent to the compiler. So wherever this constant is going to be replaced by this code before it is being sent to the compiler. Then commenting. So when we are commenting, we use a slash, then star. Then we end our comment with star and slash. So always remember your comment will be between your slashes, and it will be between your asterisks, your stars. Your commenting will be between them, and it will be ending and beginning with a slash and ending with a slash. Like I have explained, so functions provide an extra information of your code so that you yourself later on can understand it, and also another programmer reading your code can also understand. Okay, so a function body has two parts: the declarations and the executable statements. The declaration tells the compiler what memory cells are needed in the function. For example, mouse and KMS in the figure above. Then to create this part of the function, the programmer uses the program data requirements identifier doing problem analysis. The executable statement derived from the algorithm are translated into machine language and later executed. So like I said, all your code will be converted to a machine language so that your machine can understand. Okay, so that's it. But in week 3, we'll talk more about the function. So the function, when you write a function, you enclose it between the curly bracket, then you write your code inside. So later on, in week 3, we'll go deeper into function. That the function has a data type, it has a name, and it has an argument. And arguments are the parameters you pass when you call that function. Then we have the declaration. So we are talking about the function. So the declaration part. So the part of a program that tells the compiler the names of memory cells in the program. Okay, then executable statement, program line that are converted to machine language instruction executed by the computer. Okay, so the executable statement that you put in the curly bracket, they are the ones you put in the curly bracket that contains instructions. So those instructions the computer is going to follow in order to perform a particular task. So this is the definition of a constant, an example of defining constants. So like we said, you use the hashtag, then you use the keyword define, then the name of the constant, then the value of the constant. So all these are examples of constants. So we have hashtag define, miles per km, and the value is 0.62137. Okay, so before it will be sent to the compiler, everywhere there are miles per km, it will be placed by this. Then that of pi is also this, and that of maximum length is also this. So these are constant. How you create a constant? How you write a constant? So for example, if you are asked to write a constant for acceleration due to gravity, which has a value of 10, how will you write it? So I'll give you some few seconds to think about it, then I'll tell you how you do it. So 1, 2, 3, 4. Okay, the time is up. So to write the line of code for the constant for acceleration due to gravity, we said you hashtag, so you type in your hashtag, then define, you type in the keyword. So you can give the constant acceleration and the underscore, then due, the underscore, then gravity, then the value you add, so you have 10 in it. Okay, so like I have already informed you that a good programming ethic is that your constant is supposed to be in capital letters. So even though you can use small letters, it's advisable, that's a programming ethic, that you write your constant in capital letters. So people will differentiate between the constant variables and the normal variables. Then constant, you can't change the value whenever after declaring or defining a constant. So later on we will see variables, how to declare variables. Now when you declare a variable and you assign a value to it, later on you can change the value. So on the memory, that value will only be updated on the memory. But for a constant, once you define it, you cannot change it at the other part, at the later part of your code. You get the syntax error because once you've assigned the value of a constant, you cannot change it. So in the program that we'll be writing, when you create a project, normally start with int main and void and curly bracket. So int main is also a function. So we write our body of our function in between the curly brackets. So you write your code as a programmer in between these curly brackets. So based on what you are doing and the code you write. Then we have reserved words. So reserved words are words that are special in C. So you cannot use those reserved words on your own coding. When you call them, they stand for something. So even when you start typing, it will be the color is going to change to indicate to you that it is a reserved word, but it's not your words that you can use in your code. So you only call these reserved words for the purpose they are meant for. Okay. So we have a list of reserved words. We have int. So int, that's what we come to see, is a data type for integer. Then we have void. So void indicate that the main function receives no data from the operating system. So void means it's nothing. So in a function when there is void, it doesn't return anything. Then we have double. Double is for decimals. It's for data for decimal numbers. Okay, so if you have fractions and the rest, we use the data type double. So once you even start typing double, it will even change the color so that you know it is reserved word. Then we have return. So the return, after your function has finished performing a particular task, the results that you want to be returned after the function has been called is what the return comes in. Okay, So we have user-defined identifiers, and we have standard identifiers. Okay, so like reserved words, standard identifiers have special meaning. So like for example, if you call printf, it has a special meaning. If you call scanf, it has a special meaning. Okay, so the printf is for displaying to the screen. Scanf is for taking input. Okay, so we have user-defined identifiers. So you, the user, you can define identifiers, or what we call, you can declare a variable to name the memory cells where you want to put in an information or data. Okay, so you can, you yourself, you choose the name that you want to use for those identifiers. Now remember, if you are going to put data on the memory of the computer, you need to first of all name your identifier for that. In that, we call it declaring variable. So once you name your identifier, a space is reserved on the memory by that name. So you can use that name to put in values and also fetch values from that memory cell you've named. Then there are rules for naming your identifiers or your variable names. So these are the rules which we are going to consider. So rule number 1 says that an identifier must consist only of letters, digits, and underscores. So these are the three things that your identifiers should contain. You shouldn't have special characters like the @ sign and the rest. So it can contain only letters, digits, and underscores. So if you have an underscore, it's okay. If you have a digit in it, it's okay. If you have letters in it, it's okay. Then an identifier cannot begin with a digit. So you cannot start with a digit like 1, 2, 3, 4, and you can't start with it, which means that a digit can be in the middle or it can be at the end, but you cannot start your identifier with what? A digit. Now, a C reserved word cannot be used as an identifier. So the reserved words in C, you can't use them as identifiers. So like int, double, and the rest, you cannot use them as identifiers. Okay. So an identifier defined in C standard library should not be redefined. So those identifiers which have been defined by C standard library, you can't redefine them. And also there shouldn't be spacing between words or letters when naming identifiers. So if you are naming them, you shouldn't leave space between them. If you leave a space, for example, if I want to name a memory cell where I'll be putting the first name of maybe student, then if I write first and I leave a space and I write name, I'm going to get a syntax error because I'm not supposed to have a space between the words. So in that case, I can use an underscore to separate those words so that if somebody is reading my code, the person can understand what those are for. Okay, so these are valid identifiers. So we have letter underscore 1, letter underscore 2, we have inches, we have cent, we have cent per inch. Okay, so this is in a capital letter or a capital block, so we know that it should be a constant. Okay, so most often identifiers user-defined identifiers for constants we use capital letters so that it differentiates it from other identifiers. If we have hello, it's also an identifier. Variable is also an identifier. Then we have first name, last name, then first underscore name, then last underscore name. So all these ones are called valid identifiers. Now, if you leave a space between your first and your name, then it's not a valid identifier. You get a syntax error. Of course, you'll be deviating from option number 4. 5, which means that we say that you shouldn't leave a space between them. Now, although you can write your own length of characters in some programming environments, there are maximum characters you can use. So if you reach that maximum, then for example, C compiler do not consider two names to be different unless there is a variation within the first 31 characters. So we have something like this. So in the 31 characters, if there is a variation between them, if there is no variation between the 31 characters, then it's being seen as the same. Okay, so if between the 31 characters, if you don't change anything in it, then it will be seen as the same. So they will be viewed as identical. Okay, so within the 31 characters, we make sure they are different. Okay, so we have invalid identifier. So we have 1 year, then letter. But then why do you think it is invalid? I believe you know the reason why. Because you can't begin an identifier with a digit. So it's invalid. Then double is a reserved word, so you can't use it. Int is a reserved word, so you can't use it. Then the character star cannot be used to declare a variable. It can only be used later on. We will see when we use a star. Then use is invalid because the apostrophe is not allowed. Okay, so letters, numbers, and underscores are the only ones we can use. Then first with a space name is not valid. It's not valid because there is a space between the T and the N. Okay. So we have summary. So reserved words, we have int, void, double, return. Then standard identifiers, we have printf, scanf, and user defined identifiers. And your variables you declare your constants. They are all user defined identifiers. Okay, so uppercase and lowercase letters. You as a C programmer must take great care in the use of uppercase and lowercase letters because the C compiler considers such uses significant. So C compilers are case sensitive. So if you have one in a capital and change it somehow, it will be viewed as different. So for example, even though this is pronounced the same, our rate, which begins with capital R, is different from our rate which begins with small r. Then it's also different from our rate which everything is in capital block. Okay, so your naming is very, very important. If you name your variable starting with a capital letter and you are calling it and you are ignoring the capital letter, you get a syntax error because it's the C variables are case sensitive. So like I said that your constant is advisable, you can write it in the capital block, which is a nice programming ethic that you need to follow. Okay, now choosing identifier names. Then because you are not the only one who might be using your code, maybe a company bought your software. The company wants someone else to do the updating. So you normally have to use names that connote what the identifier is for. For example, if I want to name a memory on the space on the memory where I'll be putting first name, what do you think should be the appropriate name I have to give to that memory cell? It is first underscore name, or first, then the N, I make it capital. Okay, so why didn't I call it Kofi, Amber, or age? No, if somebody says your identifier Kofi, how would the person know it stands for a name? So make sure that your identifier connotes what that it is for, so that if somebody else is reading your code, it will be easier for the person to follow.
Now we are on data types. So in C, there are a number of data types. So based on the kind of information you are receiving from the user or you will be manipulating, and the data type you need to use. So for integer values, we use the int. So int, we use a data type int. Okay, that's for integer values or whole numbers. Now, if you want to use fractions or decimals, then we use double. Okay, so we use double or float. Okay, so either double or float, any of them, use them. That's for decimal point. Okay, then we also have the char. The char is a character. It's a character test. So any test, any character, which a character is a single letter. So for a char, it is a single letter. So you can have a char with more than one letter. Now the char values are normally in single quotes. So if you want to assign a value to a char, you need to put it in a single quote. And a char should be in a single letter, you shouldn't have more than one as a char. So declaring variables. So as we said, the identifiers. If you are naming identifiers to reserve a space on the memory, that's what we call the variable declaration. So the variable, when you declare a variable, it creates a space on the memory for you to put your information there or the data you get from the user. So in that case, if you are using data which you haven't created an identifier or a place to store that memory, you are going to get a syntax error. Okay, so follow the rule. The rule says that first, indicates the data type. Is it int? Is it float? Is it double? So you have to indicate all the data type of the variable you are declaring. In this way, the computer knows how much space it needs to reserve because each of the data types and the amount of space which is being reserved. So examples of variables that has been declared, we have int age. Okay, so normally age are normally mentioned in integers. For you can't have half of your age. So if you are 20 and half, normally you say 21 or 20, but you can't say you are 20.5 or 20.6 because you are exactly that number in some few months old. No. So normally age is written in integer. Then we have the year. Year is an integer. Then you have double salary. So salary is a double. Why? Because in some salaries we can have points something. So you can have maybe 20.5 or 200.50. So those ones we have salary for double. Then we also have rates for double. So we have double rates, then semicolon. Like we've explained, all your syntax, when you are done with that line of code, you use the semicolon to close it to show that you are done with that line of code. Okay, now you can as well declare several variables with the same data type by writing it in this form. So you just write one data types, then you write your names of your variables, but you separate them by commas. So like you see int age, year, then semicolon. So this one, they have the same data type, so that's why they are being declared in that way. And that you have to declare them separately. So you have int age, then semicolon, then int y, then semicolon. By here, you are declaring them all at a go. So you just call one integer, you will specify the data type to be int. Then the name will be your first name, comma, then last, then comma, then third, and so on, based on what you are doing, the way you need it. So example, we also have double salary, then comma rate, then semicolon. So here we can as well declare them all at once, or you can declare them one at a time. Okay, so we are now on assignment statement. So when you want to assign a value, for example, you've created a space on the memory and you want to put a value inside. That one, we call it assignment. So in the assignment, you use the equal to sign. So we use the equal to sign to assign something to the memory. So we assign what is at the right into or to what is at the left. So if you write the value you want to insert on the memory, is supposed to be where? Is it left or right? It's supposed to be the right. So you have the left one should be the name of the memory where you want to store the information there. Then you have the assignment operator, which is the equal to. Then you have your for whether a computation or a value at the right, which is going to assign or inserted into the memory. So for example, we have KMS is equal to KMS underscore per underscore mar times 2 mars. Okay, so here in later on you will see that multiplication, you use the asterisk or star for multiplication. So here is going to multiply the value which we define in the defined statement. There's KMS underscore per underscore mar. Okay, so the value you declared or you stated that it should be defined of that value will be over here. Then the mars value will also be here. So it will multiply each other and to return the value on the that menu so that you can access that value anytime you want. So the equal to sign is an operator symbol which is used to store the information on the memory. So what goes at the left is the name of the variable on the memory, and at the right is the value you want to insert into that variable. Okay, so that's basically the explanations of what we've done. So KMS underscore per underscore mar. Okay, so before assignment, it has this value. So it has this value. Then after assignment, then we have the save. Then it says that this should multiply this. So this will multiply that. Then the memory, we give the memory a name of KMS. So that value, and the formula is this time. So that value is going to be inserted over here. Okay. So we have the KMS per mar, we have the mars, and we have the result over here. So for char, like I said, you use a single character, a single quotation. So you have the name of the variable equal to then the character, then a single quote. Okay. So now we are on the input and output operations and functions. So we said for output, what do we use? What function do we use? We said printf is for function. Then scanf is for what? Taking input from the user. So the printf has a way of using it. So it's just print then f, then you have a bracket. Then in that bracket you can enter in the quotation, you can enter what text you want to display on the screen, and that is also going to show on the screen. Then you have the scanf, which takes the value from the user after typing as the input. That's for the input function. Okay, so in the scanf, you need to indicate what memory, whatever is being taken from the keyboard will be stored. So that one we use the end key to indicate the memory. So we have the end. So in the scan scanf, okay. So in the scanf, this is the function. So we have the scanf. Then in the double quotation of your scanf is a placeholder. So a placeholder is something that temporary is temporary there until the actual data or information that needs to replace it will be there. Okay, so we have our scanf and we have a placeholder for. So you need to learn the placeholders for each of the data types. So percentage C is for char. So if you want to use a placeholder for integer, it's percentage D. If you want to use a placeholder for double, it's percentage F. Here, this double also means float. Okay, and that of double, actual double is LF. Okay, then we use the printf to display our information. Okay, so this is an example. So in this one, the mouse is double. So we have to use the LF, so percentage LF. Then, because it's an address, we add the end key to it, so that it knows that it is an address. So once the user has finished typing, that value will be inserted into that the user's memory, or the whatever you get from the user will be stored on the memory. So in brief, we have the placeholder, then comma, the end, and the variable name. So you need to know the placeholders. That for integer it's percentage D, for character it's percentage C, for decimals or for fractions or decimals. So for decimals, you use the, which is the double of float. Then you use, if it's double, you use the LF. If it's float, you just use percentage F. So for floats, percentage F. For double, it's percentage LF. Okay, for int, it's percentage D. Then for character, it's percentage C. Okay, so we are going to write a program. This is a practical example. So we are going to write a program that the first letter. So the program asks the user to enter the first letter for both the first name and the last name. Then you ask the user the age. Then you ask the user the GPA. Then once the user has entered all those information, then you display it on the screen. So we have something like this. If we get all the information we need, we just display hello. If the user entered G for first letter of first name, then we have hello G dot A. You are, then the age the user will enter, yes or, and your GPA is, then you have the value over here. Okay, so where things are going to be placed by what the user enters, we place them by placeholders in the printf, where we display the information. So in the printf, all these ones will be in the printf, but over here is going to be a placeholder, because we get the value from the user, so we don't know what kind of value it is. Then this is also going to be a placeholder, because we get the value from the user and we don't know what the user will enter. Then the age or the years is also we use a placeholder. Then you indicate what kind of variable we're going to replace it. Then the same with GPA. Then you also use a placeholder for the GPA. Okay, so now let's start a program. Then we code it. Okay, so console application. Then next, Then this is C. Row, this is with 2. Okay, then finish. Then our code is in the sources. So you open your sources, then you click, you have your code. Okay, so as you can see the hello world. So printf hello world. So this will display hello world on the screen. So we've seen our standard header file, which is over here. Okay, so what were we asked to do? We need to get the first letter of first name from the user. We need to get the first letter of last name from the user. We need to get the age of the user. Then we need to get the GPA of the user. Okay, so now we need to ask the user to enter some things. Then we'll get it and store those things on the memory. So we need to declare our variables first. So all our variables of all the things we store, we need to declare those variables. Okay, so so now I'm going to delete the printf. We don't need. So like I've explained, your code comes between the int main curly brackets, and you leave the return over there, because it's supposed to return 0 because the function also has an int value. So it's supposed to return the same type of data that we have over here. Okay, so now we are supposed to declare our variables. So for the first letter and the first letter of last name, they are all char. So we can have char. Okay, so char fn, then char ln. Okay, now the age is an integer, and the gross salary, gross salary, it is going to be gross salary is going to be I said gross salary. The GPA is going to be double. The year is going to be int. So our years is going to be int. So we have int years or age. Should be age. Okay. Then we have double GPA. Okay. So that's it. So now we have to display on the screen, give an instruction to the user. Okay, so we give an instruction to the user by using the printf function. So here we are going to tell the user to enter the first letter of first name. So we say printf. Okay, then in the brackets we have our quotation. Then we have enter first letter of first name. Okay, so if you want it to begin a new line, or if you want it to just continue, so you can have something like this. Okay, then so that will be it for instructing the user to enter the first letter of first name. Now we need to pick it. We need to get a value. So we said to get a value from the user, we use what? Scanf. Okay, then what do we put in the scanf? The first one is a placeholder. So before you know what kind of placeholder to use, you need to know the data type of the value you are getting from the user. So our data is what? Char, because we are going to get just a single a single letter or character from the user. So it's going to be %C. So you have %C. Okay, then comma, then you indicate the memory where once the information is taken, it's going to be placed. So for memories, we use the N to indicate it's a memory. So we use the N key. Okay, now you indicate the name of the memory you have assigned. So the name of the memory for the first letter of first name is Fn.
Okay, so this one will display enter first letter of first name. Then the second one will get the value. So we can just copy and paste for that of the second name. Second name. Okay, so in the second name we have Ellen. Okay, then after that we have the year. So you have the user, how old are you? So you can print F. Let's see, how old are you? Okay, so that's it. So yeah, how or your age. So how old are you? So that is it. Then we get it from the user. The user needs to enter it. So we need to have scan F, then the placeholder is an integer. So what do you think the placeholder is supposed to be? Percentage D. Okay, then slash, then slash, so then slash, okay, so slash, then integer. So so that's why we use the D. So because it's an integer. Then you declare. So this one is what? We change it to age. This one is age. Okay. Okay. So in that case, if we are how old are you, then we enter the age. Then we click the age of the one time. Then we'll save it at the space where we name it age. Okay. So now the next one is what? Enter your GPA. So enter your GPA. Enter your GPA. Okay. So that's it. So for the placeholder for the GPA, we declare it as double. So here we use the double for the double placeholder is what? LF. Okay. And the name is what? What do you think is the name? We have the name to GPA. Okay. So that is it. So we ask the user to enter, we get it. We ask the user to enter, we get it. We ask the user to enter, we get it. We ask the user to enter, we get it. Okay. So that's basically this. Now we need to display that information. So to display on the screen, what did we say? So we can use the printf. Okay, so we have printf. Okay. So in the printf, you need to display the function exactly as it is. So where you have actual values there, you use a placeholder to temporarily hold it. Then when you assign the value, then it will place your placeholder. Okay, so let's continue. So I can copy and paste, then wherever it's supposed to be placed by the actual text, then we do what. Okay, so this one is placeholder. So percentage C. This one also needs to be a placeholder. Percentage C. Okay, then you are 20 years. So instead of 20 years, it's supposed to be also what? placeholder. So percentage D. Okay. So you are whatever will be entered here, and your GP is this one too will be percentage F. Okay. So for printing, both double and float are all F. Unless it's stand F, that double becomes LF. Okay. So now we indicate the value for each of our placeholders. So the first placeholder is our first letter of first name. So FN, and our second is LN. So we have FN, comma LN. Okay, so we check if there are other variables there. Okay, so after age is Gpa. Okay, so that's for that's it. So the next one will be Gpa. Okay, so we check if we are done. Okay, so hello. So this will be placed by the first letter of first name. This will be placed by the last letter, the letter for the last one. Then you are, and the years will come here old, and your GPA is. So the amount of money over here, then you also do that. So now we have our placeholder for our first letter of first name, then that of the placeholder for the second one, the first letter of last name. Then we have the age placeholder. Then we have the GPA placeholder. So now let's run and see what error we are going to get. Okay. Print that. Okay. Print that. I've left the F also. Okay. This happens. Okay. So let's say J, the first letter of first name, let's say J. Then this happens. Okay. So J. Okay. So it is jumping. Okay. So it is jumping the LN, the last. It's jumping the last. So if that's the case, you can just write it twice. Which when you jump it, it still move to the next one. Okay, so copying these parts, I'll repeat it twice. Okay. we have J, we have A, we have how old are you? 22. Then we have what is wrong with this advert? We have J, we have A, we have 22, and we have 4. Okay. So hello JA, you are, it's like we left that of the age, the placeholder for age, years old, and your GPA is 4.00. Let's check that of the placeholder for age. So we have 1, 2, 3, 4. Okay, so we left the age one. Okay, so you need to indicate in the order of appearance of all your placeholders. Okay, so the first one is our first letter of our first name. The second one is the first letter of the last name. And the third one is H. Then the fourth one is GPA. Okay, so 4. So we need to indicate all of them over here. Okay. So we'll run again and see. Okay, so you have J, you have A, you have A22, you have GPA 4. So we have J, we have A, we have 22, we have 4. Okay, so that's it. So that's it for this example. So remember, if your display we have it will have a variable that the user will have to enter or something that we manipulate and later display, then you have to first of all in the double quotation you write your placeholder there. So after you finish with the double quotation, then you have a comma. Then the order where of how you want your placeholders to be placed, you just indicate the placeholders, the variable names that are going to place your placeholders. So this one we have 1, 2, 3, then 4. So you need to indicate what's the first one, which one is going to replace it. The second one, which one is going to replace it. The third one, which one is going to replace it. And the fourth one, which one is going to replace it. So all this one will place all the placeholders you have in your IntF function. Okay, so let's continue. So basically that's what we have here. So you have exercise. Write a program that takes the length and kilogram mass of a cuboid. Your program should compute the pressure of the cuboid and output to the user. Then we know pressure is equal to force over area. So we need to calculate the area of the cuboid. Then we need to calculate the force of the cuboid. So it says write a program that takes the length and kilogram mass of a cuboid. So if you know the kilogram, you can calculate the force. We know force is equal to the weight or the mass times acceleration due to gravity. So if acceleration due to gravity is 10, then you can have your force as the mass. So whatever the mass the user is going to enter, then you also have your multiplied by your gravitation acceleration due to gravity. Then you get your force. So once you get your force, you calculate the area. Once you get the area, you divide the force by the area, then you are done. Okay, so this is an assignment, so you have to do it. Once you are done, if you have any, please don't post your solution, because if you post your solution, you are not encouraging others
to as well do it. So please, when you have an issue, you just message me, but don't post your solution. Okay. Now, if you also need an assistance on this week, what we learned, you can also comment, post your comment and hide your identity or write whatever you want to do. But you try to follow the code. So some of the code that I jumped, you also try to follow, because I've already explained all these things for you. So example of the placeholders. So for example, we have double salary is equal to 1,200. Then hourly rate is 8. Okay. So my monthly salary is okay. So where you are going to replace by a value, you put a placeholder there at an hourly rate of, and you put a placeholder there. Then it is double. They are all double. Salary and the hourly rate, they are double. So you use percentage F. Then after the double quotation, you indicate what kind of variables which are going to be replaced. Okay. So basically that's it. So I briefly go over, then we call it a day for this week. Okay. So we have data types. We have integer, int for integers. We have float for decimals. Then we have double also for decimals. Then we also have char for single letter. Then there are rules for you to declare your own or give name to the memory space. So to declare your name or your own identifier, you need to follow certain rules. And the rule says that you cannot start the name with a digit, and you can't use special characters. You can only use letters, numbers, and underscore when you are naming them. You can't leave a space also between them, and you cannot use a reserved word also. Okay. So when you are declaring your variables, in order to reserve a space on the memory to store the information there, you use a general syntax. You have to indicate what kind of data type it is. Then the name, you give it a name. So you should follow the rule for naming. Okay, so the name says that you can't begin with a digit, you can't have a space between them. Then you cannot use reserved words. Then you can't use special characters as well. You can only use letters, numbers, and underscore. Okay, so basically, and when you are naming, make sure that your name of your identifiers connotes what kind of data or what they represent, because this makes it easier for you as well as the one who will be maintaining your code. Okay, so we've done this. We also talk about the define. As we said that the define set a value to the constant. So before it's being sent to the compiler, all the value or the names of your constant will be placed at a value that you specify. Okay, so basically that's it. Then you are to write, you are to do the project work and run your code and make sure it's working. If you have any problem, you can post your error or you can contact me, then we can proceed from there. Okay, so these are the placeholders. You need to also master them by heart. So you know which of the placeholders you need to use in your scanf and your printf. So scanf, you have to indicate the placeholder. The placeholder start with percentage, then the type of placeholder, the type of data you are using. So if it's an integer, it's percentage D. If it's a char, it's percentage C. If it is a float, percentage F. If it's of double, percentage LF. Okay. So basically, that's it. So in your placeholders too, for your printf, so you can have placeholders and you can indicate in the order where they need to be placed. Okay. So thank you very much, and please do the assignment. It's not so difficult. You just tell the user, so just like the instruction here. So enter the length of the keyboard. So the user will enter. Enter the kilogram mass of the keyboard. Then the user will enter. Then you calculate the force of the keyboard, the area of the keyboard, the pressure of the keyboard. Okay. So you need to declare the variables to store the length and the mass. Then you define the acceleration due to gravity as a constant, because that value doesn't change. Then you use a area of a keyboard to be length and breadth to calculate your area. Then you divide your area, you divide your force by your area, then you are good to go. Okay, so thank you very much and enjoy the rest of your day. If anything, you just contact me. Bye.